Hello everyone and welcome to this advanced tutorial where we're going to be talking about displays, specifically programming the LUA code to end up with information showing up on our displays. So you can see here behind me, all of these displays feature the altitude, horizontal and vertical speed, and a compass heading. Now, they're all different sizes, so you could say this is a universal application, and even if you go into the viewing scope, you can still see that it appears, and if you go in the seat, you can see that it appears. So we've been getting these new updates that ends up with, well, they gave us a seat and the viewing scope. Previously we had all these displays, but I guess the idea behind this tutorial is showing you, teaching you how to make your own programming, how to make this work. I know there's other tutorials out there, but this one is supposed to be a universal display. And of course, I'll teach you the information where you can actually do the programming yourself and add other things, because of course if you're in a car you don't need the vertical speed, you maybe need gas and throttle or RPS, stuff like that. But this is just a starting point, and of course the expectation is that you can continue on and apply your own information that you need. But hopefully I teach you at least the building blocks, how to begin. I do want to be honest, the reason I didn't make a tutorial about this earlier, and even this one, is just there is a lot of knowledge that goes into programming. Keep in mind that's people's full-time professions. So if this isn't something that's up your alley, then I'd recommend taking a controller from the workshop, because this does apply basic coding principles. I will do my best to show you and explain, but it still is difficult without going into the basic stuff about how to program. I do recommend looking at least through this help page to kind of seeing this information, and searching on the internet just basic programming principles as well on videos. But hopefully this video can serve to get you some of that basic information. So it doesn't matter which one of these you want to use, this microcontroller will be sort of universal. So let us start with the empty microcontroller that I developed. Just basically nothing is in here. You can take another one of yours and scrap everything. And in here, we're going to start adding some nodes. Now I'm going to just call this display, but you can name it whatever it is you want. Of course, we will need our video output. So this is going to your display or seat or whatever. And we're going to want another video feed as well. And this will be an input, and this will be from our camera. Now I'll explain how to use that after, but the expectation is that at least if you're making this video, you know how to connect the camera feed to the display. That's basic. Without any prior knowledge, that should be quite clear. Of course, we're going to make it a little more complex than that, but you have your seat, your display, and your camera node. And then we're going to want whatever sort of information we want coming into here. So for example, we're going to want our compass. That's one of them, and that'll be an input. We're going to want our altitude, and that's going to be as a number input. And then in the case of a helicopter display like I was showing, and that's pretty much what we're going to be building here, but again, you can take this and change it to whatever you want. We're going to need our horizontal speed and our vertical speed. So now that we have all these different nodes here, we can of course update it, apply it. I'd recommend just saving it just so you have a starting point. And then we can now go into the actual game, or into this. So as we had, you'll want to connect these, and I'm just holding control here. I'm just going to connect it to all of these, and this one can go to our camera feed. Now we'll have to spawn up these other things, so we can start off with the speed sensor. We'll throw that here. We'll put two of them. The left one can be our horizontal, the right one can be our vertical, and we'll connect this horizontal to the horizontal speed, vertical to vertical speed. Then we'll need our altitude meter. We'll put that here, and we'll need our compass or compass sensor. So we'll put that here, and you'll want it facing the front of your creation. Now that compass will go to compass, altitude will go to altitude. Of course, we need a battery, we need a constant on for the displays, that's back here. All of these are attached. I just need to take one and put one to the compass here. And the constant on, just so we have our displays working, but your creation may have a button or whatever. So we've basically wired this microcontroller. Of course, there is nothing in here. So as I always do, first on the left hand side we're going to put our inputs just so they're easy. On the right hand side we're going to put our outputs, so then we just know we have to connect these things. Now before we even get into the Lua coding, because that's obviously what you're all here for, just going to finish off the microcontroller. So we're just going to place the Lua block, but we're going to have a composite input for the numbers, as you see here. So that's very much needed when you're having something like this, and we have 4 of them, so we're going to set it to 4 channels, and then we have to set ourselves up with the order we want. Now the way I want it is the altitude first, that'll be number 1, our horizontal speed second, vertical speed third, and compass fourth. Now that's just my preference, and that's going to be reflected in the Lua code. And of course we have to take this signal and put it into the data input on the Lua. Now we're going to just want one other thing, and keep in mind how we've added a camera feed, but there may be instances where you don't want a camera, and like I said, I'm making a universal microcontroller. So what we're going to do is just go to video, and it's going to be a video switch box, and I'm going to add that camera to the on signal. And then what I'm going to do is put a toggle switch and put it here, and it'll just say camera feed. And the reason why I'm doing that is because if you don't put this, then you're going to end up with that kind of fuzzy, it may just be like the sandstorm or whatever they call it, snowstorm, where it's just like the pixelated thing. Anyways, that if you toggle this on, the camera will be on, and then we're going to attach this to the video input, and of course this goes to the seat itself. So if we want camera to be on, then we can toggle it, otherwise we can keep it off. Just to give you an idea, in the other microcontroller I made, it's pretty much a camera pass-through, and if you set it to off, then your displays will just be showing nothing coming out of them other than the coding information. So to show you, it looks like this. So if we don't want the video feed through, then it's just a display as such. Comparing to this, so if we have the video pass through on, we get this. Now of course on the viewing scope and in the drive, well specifically the driver's seat, it does nothing, because in the driver's seat we're actually using whatever our character sees. On the viewing scope it's actually imperative, because on the viewing scope, if you don't have the video pass through, then there is no camera feeding what you're supposed to be seeing, and then you just end up with black, which makes no sense. So you want to have video feed if you're using a viewing scope, whereas this driver's seat, even if you have a video feed with a camera, it doesn't do anything. So keep those things in mind. Now for the actual displays themselves, that does make a difference. And yes, what you can do for the case of a seat or whatever, if you're making it specifically to seats, you don't even have to have a camera pass through. Whereas if you're making it for a viewing scope, then you'll probably just want this directly here, and you don't even need any of this, because you always have to have your camera if you're doing one of the viewing scopes. So just keep that in mind. For me, I'm just keeping it very universal, so you have the choice and the control to set whether or not you want your cameras passing through. Anyway, now we are on to the Lua script. If you open this up, this is what you get the first time. So it shows you this. Now, again, like I said, if you're new to this, don't panic. I'm going to give you the code so you can actually place it in. But keep in mind that you have to at least understand what's going on. So we have our function, which is pretty much a calculation that runs behind the scenes. And we have our we have our function on tick, which is behind the scenes. And we have our function on draw, which is pretty much things that are showing up on the display. Now, again, don't panic. You got to kind of take it easy and understand what is going on here. So right now, we have some information. Now, this is a good starting point. It'll tell you value, input, get number. Now, the way coding works at a very basic level, and I'm a structural engineer, but I did take coding classes in university, so hopefully I can explain this okay to you, is we're getting a number here from our composite. So that's actually being fed from this data input. But right now we're only extracting input number 1, which is our altitude. So, and it's being called value. So right now it's just being called value. It's not being called anything else. So you have the ability to set a type or descriptive. You don't have to use value. You can use alt for altitude, for example. Next, what you're going to want to do is actually copy this over a few times. And we're just going to put it like this. So I actually went back. So this one, we're going to want it to be our altitude. And that's our number 1, remember? Now we're going to set this to 2, 3, and 4. And if you remember, first we had our horizontal speed. Then we had our vertical speed. And then we had our compass. Now keep in mind, here you have the ability to set whatever you want. You can keep going. You can make whatever, as many inputs as you want. I think we have 32 inputs available to us. So you can put a lot of different inputs. And like I said, if you want RPS, if you're doing an engine or gas or whatever. But in essence, for this one, we're just keeping it like this. What's important is you have your get number 1, 2, 3, 4. So those are imperative. Now, we don't have an output. We're not outputting anything, so we can actually remove this. And if you're not familiar with coding talk, these 2 double dashes make it a comment. So if it's grayed out, these things are all comments. They don't affect the script. Whereas if you make it enabled like this, it's going to read an error. You press this button, you're going to be getting syntax. What is going on? What is this line? So you can remove that. You can remove all of these comment lines if you want, but in essence, they're not affecting the code. Only this stuff is. So right now we're getting all these numbers here, and this is reading, so 1, 2, 3, 4 into the code, and it's going to be used to actually work it. Now, you can go on writing the whole code in here, but there is a super useful tool on the internet that lets you write codes without jumping back and forth, testing it out in your creation. You can actually write it. So what we're going to do is actually go there. What I'm going to do is actually copy this, Control C, and then go into the internet browser. Just a word of advice, when you are copying this over, you want to leave your desktop view while you're in this screen. If you leave your desktop, if you leave your game here, if you press the Windows key and go to your desktop while you're here, the game actually sometimes glitches and it'll just turn into this kind of like light blue screen of death. So you'll want to keep it here. Just a little tidbit that I kind of learned while I was jumping back and forth on my screen out of the game. Leave it here and then go out of the game. So the tool is called Pony IDE. I've given the link in the description here, and it's on the internet. And what's super cool is it was developed for Stormworks, so specifically for Stormworks, and you can actually use a builder tool here to set buttons and graphs and shapes and stuff, but I'm not going to get into that here. We're going to be writing our own code. You also can use some auto generation tools, whatnot. Now, there may be a code here when you join. Just Control A, delete it all, and put your own code. Now, you could see there is no display, but if we go to monitor here, you can actually see that this is set to a 3x1. So you have the ability to select what size monitor you want. Let's just start off with 1x1. You'll see that it's small. And if we press this button up here, start, it will show up like this. So it's going to just give whatever we had. Now, what it is doing is showing this on function stuff. Now, we have to remove all that. And if we press run, you see there's nothing. So right now, your code is non-existent. What I'm talking about specifically is the code on the onDraw function. So I just cleaned it up. I just deleted all the comments, all the other stuff. So remember, all you'll have at this point is your altitude, horizontal, vertical speed, and compass, and nothing here in the onDraw. So right now it's obviously not drawing anything. Now, one thing that I kind of did through trial and error, and I'm just going to tell you how to do it, is math.floor, and then put an open bracket, and then put your input get number, and then you'll want to multiply by 1.943844. And that's the conversion from meters per second, which is the base unit coming out of your speed sensor, to knots. We're using knots in this case. If you're trying to use miles an hour, kilometers an hour, you have to put a different conversion factor here. And then what I've done is just plus 0.5. The reason for that plus 0.5 is to round it up. And so it actually shows 0 and we're at 0 and whatnot. There's just a lot of things. Trial and error got me here. Now you can copy this whole thing over, Control C to here. Just keep in mind, you got to switch this to 3. So with that being switched to 3 now, you actually, I'm going to zoom in so you can actually see the code a little better. So now you have your input 1, your 1, 2, 3, and 4. So all it is the horizontal and vertical speed now have been multiplied by the conversion factor. Yes, you could put it directly in your microcontroller with a function code to convert it before it even enters here, but I like doing it inside the LUA script. That's all you need for the onTick. All right, now we get to the onDraw. And actually, if you recall, I deleted everything, but there was some valuable things that I shouldn't have deleted, but I'm going to type it out here with you guys just so you understand what it is. So look here, width and height, 32, 32. Those are that's the resolution of this display. If we go to the 3x1, it's 96 by 31 or 32, sorry. Now you have the ability to actually have your microcontroller understand what size display it is. That's a super useful function. So you actually can have the W and H, and W will be this function, which is screen dot get width. You have to capitalize this. You have to have it exactly looking like this. And then H will be screen dot get height, and capital H for the height, and just like this, close bracket. So now what's happening is our code is actually pulling this information from the screen and putting it into here. And the reason why this is important is because, and I'm just going to add a bunch of enters here, pretty much you can keep your end at the very end. We're going to get to that later, but you have the open function now on draw, and then you'll say if W is equal, and you've got to put 2 equals to 32, meaning if the width is a 1x1 display, so the smallest of the small, then, and you have to know your if-then functions, and then we have a code here. So the code will be whatever. I'm just going to leave placeholder for now. And then what you're going to want to do is go down here, else. So this is just an if then else function. And I'm just going to also put placeholder, and then we're going to end. So if the screen is 32, then do this, otherwise do this, end. And I'll explain that all in a second, but pretty much that's your first introduction to if-then functions, which is basic programming. You have to learn basic programming if you want to write codes. So we're going to start off with the 32 resolution screen, not 32 inch, and that's going to be what's happening here. And the reason why we're doing this is because the 32 width screen is the narrowest screen. So you're obviously going to have some things happening there that bigger screens can take more code, wider code, whereas the 32 can't. So if you're only wanting to write a code for a 1x1 screen, all you need is this portion. Now what we're going to do in here is start off with screen dot set color. Again, you have to have the capital C. That's a very important part of the code. And we're going to put 0, 32, 0. We're just setting up ourselves for the first portion. And then you want to have screen dot draw. And all these you can copy and paste after a while. I'm just going through the motion. Text box. Capital T, capital B. You have to have it. And then you do 1, 2, 16, 5. That's setting something I'll explain in a second. And then comma, and then quotation marks A, comma, -1, 0. Now, sounds like gibberish, but if you press stop and press play, you're going to see an A popped up in this location. So what we've done is we've drawn A. Now I can draw whatever I want. I can draw altitude and it'll show up like that. But because we're doing a small display, we're only going to do A like this. And what this does, so this one, and I'm going to explain it once, so I'm not explaining it after, sets the horizontal push. So we're 1 pixel from the end. If I put 5, you're going to see it's going to move 5 away from the end. So I'm going to leave it 1. The 2 is how far it is from the top. So I notice I have to keep pressing stop and play. But if I put 7, this is going to move down by 7. So I'm going to leave it 2. Now, because this is a draw text box, you have to imagine it's drawing a physical box here. It's not just open-ended start here, right? It's a box, and we're setting the width and the height. So 16 is how wide it is, and 5 is how high it is. So in the case of writing something like altitude, and if I press that, look what happens. And that's because that's 16. Now if I make this 32, it's going to extend it to the full width of the screen. But we don't need it to be the full width. We're happy with 16 because we're happy with just a simple A here. Now, the -1 is saying I want it to be justified on the left side of this text box. Keep in mind, it's a box. We're now -1. We're justified far left. If I put +1, it's going to be justified at the end of that box. And if I change that 16 number to 18, it's going to move out because it's now, this is the end of the box. So the box is where my cursor is kind of going. So I don't want it to be justified to the right. I want it to be justified to the left. If you put 0, it's centered. So that's kind of how this works. And then this one is the vertical direction as well. Now we're centered in the vertical. If I do -1, same situation, it, I believe, pushes it upwards. But because we've only made it 5 wide or 5 tall, that happens. If I make it 16 tall and set it to 0, it should drop down there. Whereas if I put it to -1, it'll go back to the top. And if I put it to +1, it'll go down to the bottom of that 16 square. Now it's a square like this. Anyways, we're quite happy with 5 and quite happy with just centering it on that 5, just like this. So that's a basic intro tutorial to writing a text box. Now I'm just going to copy and paste this thing a few times here because we need it to be happening a few times. So the first one is A, the second one is H, the third one is V, so horizontal and vertical speed. And again, I've trial and errored this, so what we're going to want is 1, 9, 16, 5. Keep in mind, these stay the same. And then the third one is 1, 16, 16, 5. And if I do this and press play, now we get our assortment of altitude, horizontal, vertical. Perfect. that gives us the first kind of intro to text. That's just text. You can draw the label brand of your company this way or whatever you want to do. And now what we're going to do is copy this screen set color, because this color is green. So keep in mind, I kind of skimmed through that. You could go to color picker and set whatever color it is you want. See here, it's 6511. So if I put 6511 and press play, it's going to turn to that red. So you can choose your colors and have them pop up. Now, the next time I set a color again, now the color for whatever I put beneath here will change. So likewise, you can actually put colors like this and make this be whatever you want. Let's say 055. You gotta put that comma. So now the top one is going to be one color and the rest are going to be another color. But because I want it all to be one color, I'm just going to have it like this. And I believe I previously, if I just go Control Z, I can remove all this stuff I've done and kind of go back to this, which is 0, 32, and 0. And that makes it this kind of army green, dark green. Now we're going to want a color again, because this time I want it to be gray. And that color is going to be 0, just 40, 40, 40. And now we want to draw our text boxes again. Now I'm just copying code to speed things up. So draw text box, and now I can set it to 9, 2, 15, that's the width, and 5. That's okay. And in this case, I'm actually going to want it to be 0 and 0. And now if I press this, we get an A. But we don't want A. What we want is the number we're pulling from here, which is get input number 1, ALT. ALT is the code we have to refer to now. So now I'm going to teach you how to link things to this code. So what you want to do is string dot format, open bracket, and then you put a quotation mark, you put a percentage, dot 0f, close that bracket, comma, ALT. That is going to now reference ALT and put it in this format with this rounding. This is what kind of this is, and that number is now being pulled. You can see here, I didn't go through this, but you can set information on this program, on Pony IDE, and right now it's telling us 32. Why is it telling us 32? Because we're linking input 1 to this number. So if I change this, this adjusts. Now, screen width, screen height, touch, and touch, 1, 2, 3, 4 are reserved for touch screens. But because we're not making a touch screen, we can actually use this one. I would say it's better practice to start with 5, make this 6, 7, 8, rather than messing with 1, 2, 3, 4, which again, like I said, is reserved for touchscreens, but we're not making a touchscreen, so this doesn't affect us. And like I said, you can test the numbering, and if you press this, you can actually change how high it can go, and you can kind of see how it functions when it becomes a single digit, double digit, and triple digit number. That's why I like to keep it centered. So that's why I have 0 and 0 here. Now, one last thing what we'll need is the unit. Now we're going to copy again this line, paste it here, and in this section, we're going to put M for meters. And we're going to want 0, 0 here. We're going to want it centered, but now we've got to change the code here. And again, through my trial and error, what we're going to put is 24, comma 2, comma 6, comma 5. Delete everything else. And if we press run, boom, now you have altitude is 32 meters. Now what you'll want to do is copy this code a few more times. You'll just want to get to a new line like this. You'll want to copy it 3 times to go to altitude, horizontal, and vertical. And in this case, what we want to do is just change the numbers, because if you spawn this open, now you kind of just have it repeating in that top one. So if I change this to knots, KN, and this to knots, and keep in mind your display is always going to be in caps, so even if you put lowercase. Now see what's happening there. First of all, that 5 or 6, sorry, isn't wide enough. So we have to adjust our numbers here. So the numbers that through my trial and error is 7, 9, and 15, 5. That's the first bit here. And if we go down to the knots for the, and we don't want altitude, of course, we want the, if we go up here, horizontal speed. So we're going to copy that horizontal speed, paste it here. This one is our vertical speed. We're going to paste that there. So this portion looks good. 7, 9, 15, 5. Now the knots, the speed, is going to be different. It's going to be 22. It's going to be comma 9, comma 10, and comma 5. So if I press play to that, you get this. Now keep in mind that top line is still here. So you want to change the numbers to this. So 7, comma 16, comma 15, comma 5, vertical speed, that's good. And then down here, we want 22, comma 16, comma 10, comma 5. And if I press play on this, boom, now it actually looks like something. So that is your first exposure to writing the code for a small display. Now we've not put the compass, and I'll explain that later, but we have this portion. So now remember how I had this placeholder for else if we have a widescreen? Well, if you have a widescreen, you want something else. So we're going to copy this code first here. So it's the identical code for now, but now we're going to change some numbers. So remember how I told you that we are working with a wider screen in this case. So now we could actually write out the ALT rather than just a simple A. But before I even get to that, I just want to show you that if you press play, your screen will be blank. If you go to the 1 by 1, the code appears. Why is that? Well, it's because when you have this placeholder of nothing and you go into 3 by 1, you get nothing. But if you copy this to here and press play, it appears. Now, first thing right off the bat, what we're going to want to do is have this code centered, because now when it's not a 1 by 1 small screen, we actually can use the screen to our advantage, and we put W divided by 2 minus 15, and if you press play on that, you'll see it appears here. And if you go to a bigger display, it'll appear centered. So that just centers it nicely. Not 100% centered, mind you. It's where I want it to be. I want it to be just left of center, because here's center. I want the 96 meters to be here. So we're going to copy this, copy paste over top of the 1. And if we press play, these have moved. Now we can actually set the rest of the code. Now you don't have to do all caps, because it will show up always all caps in your display. But you do something like this. So that's done. This portion's complete. And now we go here. So for this portion, we have to change it as well. So W divided by 2. And then you could leave 2, 15, 5. In fact, you could leave everything. You just have to change this portion here, which is W divided by 2 plus 16. That offsets it. So if I press play, it puts it over there. And you'll want to copy this W divided by 2 to all the ones that pull the number, and we're going to want to copy the W2 plus 16, or W divided by 2 plus 16, to all the ones that are the units. There you have it. So now no matter what size screen you put, it's always going to remain kind of in that center space. And it's really useful. It's not directly center, mind you. You can fine tune it to the left. I was quite happy with this because I wanted it to read like this line is the center, rather than it being this where I'm hovering my mouse to be centered. So that works for me. Now, one other thing we can add, and this is a new thing that we didn't show you yet, is a line. You can draw a line like a crosshairs in the center, but first we'll grab the set color function, because that color is going to affect that line. Now we're going to put 60, 60, 60, and comma 20. Now you can see here we actually have a fourth part, whereas here we don't. That fourth part is transparency, so we've actually set it to be transparent. And you could see how this works. If I do a comma 20 here, that becomes very, very faint. So these are 100% opaque, or 0% transparent, whereas here we have a 20% opacity. So if you go 90, it becomes more visible. If you go 10, it becomes less visible. It's only 10% visible. So 20 is 20% visible. And then what we're going to do is screen, got to spell it right, screen dot draw line with a capital L, and that is now drawing lines. So just for the sake of argument, if you put 4, 5, whatever, 20, 20, and ran this code, you can see the faint line there. Now I'm going to turn this off for the time being just so you can see where we're putting it. So that is drawing a line. But we want to put that line, position that line in the dead center of the display. So for that, what we're going to do is a code. W divided by 2 minus W divided by 32. Sorry, over here was supposed to be W divided by 2 minus W divided by 32. And I'm just going to delete everything here so it's quite easy to read. So W divided by 2 minus W divided by 32 multiplied by 3, comma, H divided by 2, that's height. Now we're talking about height. And then comma W divided by 2 minus 5, comma H divided by 2. So it's the ends and starts of the line. So now you can see it looks like this. It's not going vertically. Something's wrong with the code because this shouldn't look like that. So we can take another look at the code and see what I did wrong here. So I found it. It's supposed to be H divided by 2. So if you make a typo, not a big deal. You have to learn how to also diagnose or to troubleshoot your code. So when things aren't working, that's why I often hit play, just to see that what I'm drawing is what I want it to be shown. So that to me is good. That's the left side of the crosshair. And I'm going to copy this code over now 3 more times. So we end up like this. And then we're just going to be changing these values. So for this second line, we're going to want it to be W divided by 2, in this case plus the 32 divided by 3. Second portion is good, H divided by 2. Then here we want to also go plus, and that's good. And if we run this, boom, it appears over there. For this next one, we don't want this portion. We just want W divided by 2. And then H divided by 2 minus H divided by divided by 32. You got to follow the screen. Don't listen to my talking. I'm trying to type and trying to talk at the same time. Multiplied by 5. And then here, W divided by 2, we could remove the negative, or minus 5, and we're going to add that here, minus 5. So if I run that code there, we get a tall crosshair in that direction. So you can see the code is kind of opposite of the other one. I'm going to copy and paste it here and change the signs. We're going to go positive here and we're going to go positive here. And if I run that, it appears on the bottom. So yeah, you can now tweak this and make it better. I don't like that these are so small here. But keep in mind that's because we're at a 3x3 display. If we go to 5x3, then it starts to look a little more natural. So funny enough, this code was written on a 5x3 display, and that's where these numbers came from. So that's the downside of using H and W in the code, is when you change this, it will physically change the size of that crosshair. But I usually found, and especially say 9x5, it looks perfect. And it was written for 5x3, I think, and 9x5, which is the seat size of displays. So that's okay with me. The crosshairs for a smaller display really aren't important. I rarely use a 3x2 for, and 3x2 actually works fine. It's the 3x3 and stuff. Now we're going to add one last line here, which will be screen dot draw. And now we're going to go rect, R-E-C-T, F, which is filled rectangle. If you go this and draw it, it's going to be a box. Whereas if you press F, it'll actually fill whatever is in the center of that. And now W divide by 2, comma, h, divide by 2, comma 1, comma 1. That's going to give us a little dot dead center of the screen. Now keep in mind, this isn't how Stormworks may show it, so it'll actually be more centered in Stormworks, but there's obviously limitation. You can't go half pixels over, so that is what it is. And now we're going to implement that comma 20 here, the transparency, and it gives us a very faint outline there. Of course, when you are in the game, you would absolutely see that. So here you don't. Anyway, that finishes this portion. Now the last thing remaining is the compass. Now the compass gets a little more complicated because you're actually taking a number coming out of the compass sensor and translating it into a direction, north, northwest, west, whatever. So it gets a little dicey and it'll end up being a long code, but hear me out. Local direction. So that's establishing the calculation equals, and then these two, because keep in mind here, we only have comp, C-O-M-P. We don't have anything direction. So now we're introducing the direction function. And now we're saying if compass, so now we're referring actually to the compass heading, is greater than or equal to negative 0.0625, and compass is less than 0.0625, then direction equals north. So that's the first part. So if our compass is between those 2 points, then we're going north. Now that's just trial and error. It's finding where the compass is pointing and whatnot. So you just have to live with it. There's really no better explanation than that. And now what you're going to want to do is copy this over a bunch of times because you have to set it for each direction. So we have the north one complete. Now we got to do the second one. So now if the and then keep in mind, we got to go else for all of these. So I actually shouldn't have copied it until I added the else if, because if you just keep it if, it will not work. You have to, the game relies on if then else statements. So you got to do that. So if it's this, then north. Else, if the compass is, and now we just have to change this. So we change this to go, if it's positive, this, and if it is greater or less than 1875, then we are northwest. And then it goes on. So it is a bit tedious. And now we're just going to copy this to here. But once you establish it once, you could use this code in many different places. 0.3125. Then we're going pure west. Now we're going to take this. We're going to put this here. Here we're going to now have a different number, 4375. Then we're going southwest. So you have to bear with me. I'm showing all the steps. I don't really want to skip ahead. Southeast, east, and then we need this once more for northeast, because I want to show you exactly how to program it. I want to show you the thought process. So now we have it. North, northwest, west, southwest, south, southeast, east, northeast, and then we're back north. We just have to finish these numbers. So this one we can now copy. We can place it here. So you could see, and then have this be 0.5 or 0.5. The one thing you have to change in this one is actually you put it equal here. So now if it's equal this, and if compass is equal this, and then you have to add a second part, or if compass is greater than or equal to negative 0.5, and compass is less than negative 0.4375, then you do this. So that's just kind of this statement, and you see here now it's telling me there's an error. So we have to go and diagnose where that error is, and expected key. I see. So I actually have to add an open bracket here. And then also close the bracket here. So that, oops, it's still coming up with that error. Is it because I have a space? And a space? No, that's not why. It's still unhappy. I see. We can't have the then. So again, coding, trial and error, mistakes, issues, all kinds of stuff. You have to be patient and have to try it out. I'm just telling you what I put, but if you're writing it out yourself, then it needs a little bit more brain power, of course. So now we have it. Compass is between those, or if compass is between those, then we're heading south. And that's just the way the compass sensor works. So you definitely have to be patient with it. All right, next one. Then we go here and we're going to grab this 0.43. We're going to paste it here. And now we have negative 0.437 or negative. It's so prone to typos when you're doing it like this, but it is what it is. I really want you guys to have a full idea of what went into this. And maybe it's going to scare some people, but I'd rather some people be scared than to think it's easy, because ultimately coding is not easy. You have to have a certain mind for it, and you have to get there. So it repeats itself, okay? So we ended up taking these numbers here, and then after this midpoint, it repeats itself. We have the 0.43, and I think, yeah, negative 0.43 to negative 31, or 0.31, negative 0.31 to negative 0.187, which is the same one here, 0.187, 0.625. Take a good look at these numbers, pause the video here, and use this, okay? Don't go with what I told you. You want to make sure the numbers are right. And not just the numbers, but the convention. So keep in mind, here we have negative to positive, and then all these are positive. Here we have these two positive, these are negative, and then all of these are negative. So you got to do that. And when you're done, you got to end. Otherwise, it won't work. Now, if I press pause and play, nothing happened, because all this is a calculation. So that's what gets us now to the next part, which is actually making this direction show up on our display. And you go screen dot set color. And again, you want to set a color now for the compass. We're going to use 10, 10, 10. And then what I've done first, and you could not use this if you want, but I've actually drawn a triangle. That's filled, triangle F, and then put a code of W divided by 2, close brackets, minus 10, comma, H minus 16. Again, trial and error, folks. This is something that you just have to type out, because I spent a lot of time and effort getting this going. So H minus 16 multiplied by H times 100, comma, W divided by 2, close bracket, comma, H, oh yeah, we want a bracket. No, we don't want a bracket. H minus 25 multiplied by open bracket, H divided by 100, close bracket, comma, open bracket, W divided by 2, close bracket, plus 10, comma, H minus 16 multiplied by open bracket, H divided by 100, close. Yes, it is complicated, but what is this going to do? It gets us that nice little triangle that you see here on the bottom of the screen. It's kind of like my car has a compass and it has a little display thing like this, and no matter what size screen you set it to, the triangle will auto adjust. So that's kind of nice. And now finally, for the final bit, screen dot set color, and you could have copied the line above. I'm going to do that actually. And then we just change it. I'm going to put 40, 40, 40. And then we want the next portion, which is screen dot draw text box. You could have copied it from the code above. open bracket. Now, 0, comma, h minus 20 multiplied by, open bracket, h divided by 100, close bracket, comma, w, comma, 5, comma, direction, comma, 0, comma, 0. All right, let's see if it all works. Boom, north. No matter what size you put, you'll get that little thing. And if you change direction, this will adjust. So we know that we're referring to number 4 for the compass heading. So if I actually drag this out, now keep in mind if you put 6, it doesn't really work, but you can go here and set the minimum and max to like 1, and then you can have them super small like this. And if we oscillate the numbers, you can actually see it changing here. So as this number changes, these here will change, and it just makes sure that everything is running nice and dandy. That is pretty much the code. So then what you'll want to do, Control A, copy it, Control C, and throw it into the game. Inside the game, you go to your Lua script, Control A, Control V, check for errors, no errors, done. Boom. A lot of talking, a lot of random numbers and stuff, but we're going to finally see if this works. So we're going to throw this on, make sure everything is connected, make sure it's putting on the displays, the camera feed is coming in. We're going to want camera feed off for the first test. Let's spawn it up, and here you have it. So you could see it's working like this, and on this one we actually have the crosshairs, whereas on the other one I don't have the crosshairs. So I'm going to see why that's happening. But you can see, actually, I think we have them. They're just too faint to even make out on this black. Because if we turn on the camera feed and we spawn it up again, no, you still don't see them on all these. Anyways, what you do see is that on the small display, we have it A, H, and V. On these ones, it's centered, looking much better. On our viewing scope, it looks nice. And on our driver's seat, it also looks nice. So that did work. You could see that it's working. So now you ended up with a code, and if you spin this thing around, I guess it's too heavy for me to spin around, but if you spun it around, this would be pointing in a different direction. It would change that compass heading. So in here, we can find the line item where we drew that crosshair, and it's right here. So we set it to 20%. If we go ahead and put 50%, that should get it shown up on the displays, I'd think. No, it doesn't. But on the seat, it shows up a little crisper. So 50% shows up crisper, whereas here it does not. So we got to run back to the drawing board and see what is going on. Again, this is kind of unintended, but it is a good learning experience to see what exactly is going on and understand the code. It appeared that it was just too faint to be visible. So if I put it to 80% here on the crosshairs and spawn it into the game, then we're going to see there is going to be very, very faint lines. Like super faint. That's 80%. If I go here, you can see it's pretty visible here. For some reason, not very visible on these. So if you're set on having those crosshairs on your displays, then I'd honestly recommend not setting any transparency. Just remove that, have it 60, 60, 60. And then when you spawn this into the game, you're going to see the crosshairs show up just nicely here. So fine-tuning, changing colors, setting things, I highly recommend you do it all. I mean, maybe you don't want this green, gray, whatever, you can change it. If you watch the full video, you'll have a pretty good idea of how to do these, how to set these values, how to end up with something like this. And like I said, you can put RPS, you can change this, you could change this. We went through the steps. If you have any questions, post it in the comments. Others will help you, or I will, but in essence, yeah, if you want to change this to RPS, you just have to put RPS here. And then you'd make this feed change names. You'd make this feed change names. Again, rewatch this video if you have to. It should answer a lot of your questions because we went through step by step on how to set all this up. But anyways, I think that we covered a lot of ground. It's a long video, but it should provide those that want this type of information. It should provide them some good information. You can see here, it's pretty distracting if they're 100% opaque, but the display does give us some transparency, which is interesting. It's kind of still an overlay. It's not 100% opaque. Anyway, thank you all for watching. I want to thank my server boosters and YouTube members for the support. I want to thank the community, and hopefully you guys learned something. Stay tuned for more videos. Stay tuned for more creations and all kinds of fun stuff. So thank you all, and see you next time.